The Southern Ocean, a realm of icy winds and powerful waves, is home to a force of nature unseen by most, yet crucial to the balance of our planet, the Antarctic Circumpolar Current, or ACC. This immense flow of water, the largest ocean current on Earth, encircles the Antarctic continent like a liquid embrace. It acts as a vital artery in the global ocean circulation system, transporting heat, nutrients and marine life across vast distances. The ACC plays a pivotal role in regulating Earth's climate. It draws warmer waters from the Pacific, Atlantic and Indian Oceans southward. As these waters mix and cool near Antarctica, they sink, forming deep water masses that flow back towards the equator. This constant churning helps distribute heat around the planet, influencing weather patterns and moderating temperatures worldwide. The Southern Ocean, isolated by the ACC, also acts as a massive carbon sink, absorbing a significant portion of the carbon dioxide released into the atmosphere by human activities. This absorption helps mitigate the impacts of climate change by slowing the rate of global warming. The ACC therefore plays a crucial role in maintaining the delicate balance of our planet's climate system. However, this vital current, the unsung hero of the Southern Ocean, is facing a growing threat from a changing climate. As global temperatures rise, the delicate balance that governs the ACC's strength and behavior is being disrupted, with potentially far-reaching consequences for our planet. The warming effects of climate change are most pronounced at the Earth's poles, and Antarctica is no exception. Here, rising temperatures are causing glaciers and ice shelves to melt at an alarming rate, releasing vast quantities of fresh water into the Southern Ocean. This influx of fresh water is altering the delicate balance of the ACC. The ACC's strength is driven by differences in water density, which is influenced by both temperature and salinity. Warmer, fresher water is less dense than colder, saltier water. As the Southern Ocean receives more fresh water from melting ice, its surface layer becomes less dense. This reduces the density contrast between the surface and deeper layers, weakening the downward flow of water and slowing the ACC. Scientists predict that the ACC could weaken by as much as 20% by the end of the century if current warming trends continue. This weakening could have profound implications for the global climate system, disrupting the ocean's ability to regulate heat, carbon dioxide, and other important elements. The ACC's weakening is not just a prediction, it's already happening. Recent studies have shown a measurable slowdown in the current over the past few decades, and these changes are expected to accelerate as global temperatures continue to rise. The consequences of a weaker ACC could be felt far beyond the Southern Ocean, impacting weather patterns, sea levels, and marine ecosystems worldwide. The interplay between salinity and temperature is crucial to understanding the ACC's response to climate change. The Southern Ocean, while cold, is actually less saline than other major oceans. This is due in part to the constant influx of fresh water from melting glaciers and ice shelves. This fresh water acts like a lid on top of the denser, saltier water below, contributing to the layering effect that drives the ACC. However, as climate change accelerates the melting of Antarctic ice, the volume of fresh water entering the Southern Ocean is increasing. This disrupts the delicate balance between salinity and temperature. The increased freshwater input has a two-pronged effect. Firstly, it reduces the density contrast between the surface and deeper water layers, directly slowing down the ACC. Secondly, the influx of fresh water alters the formation process of Antarctic bottom water, a dense, cold water mass that forms near Antarctica and sinks to the ocean floor. This bottom water is a key component of the global ocean conveyor belt, a system of interconnected currents that circulates water and heat throughout the world's oceans. The weakening of the ACC and the altered formation of Antarctic bottom water could have cascading effects on this global conveyor belt, disrupting ocean circulation patterns and impacting climate regulation far beyond the Southern Ocean. Section 4. Disrupting the global ocean conveyor belt. The ACC is not an isolated entity. It's a critical component of a much larger system, the global ocean conveyor belt. This vast network of interconnected currents acts like a giant planetary plumbing system, circulating heat, nutrients, and oxygen throughout the world's oceans. The ACC plays a vital role in this system, connecting the Southern Ocean to the Atlantic, Pacific, and Indian Oceans. As the ACC weakens, its ability to transport heat and nutrients around the globe is compromised. This disruption could have significant implications for marine ecosystems which rely on these currents for food and oxygen. Furthermore, the altered circulation patterns could lead to regional changes in ocean temperature and salinity, impacting weather patterns and potentially exacerbating extreme weather events. The weakening of the ACC could also impact the ocean's ability to absorb carbon dioxide from the atmosphere. Currently, the Southern Ocean acts as a significant carbon sink, absorbing about 15% of human-caused carbon emissions. However, a slower ACC could reduce the ocean's capacity to absorb carbon, potentially accelerating the rate of climate change. The interconnectedness of the ACCC with the global ocean conveyor belt highlights the far-reaching consequences of its weakening. Changes in the Southern Ocean can ripple throughout the planet's oceans, impacting climate, weather, and marine life on a global scale.